Yes, sir.
Okay. So basically, if you see that in this question, two capacitors are used. So that means this particularly filter is a second order filter. Now we have to calculate the output upon input transfer function of this one. So how we calculate that?
Sir, the gain of the amplifier is 1.
Yeah, for basically for this part, we are not taking the gain. We are basically solve it using the nodal voltage. Okay, so we are considering that this is the my VA. Okay, and this is VB. Now can you apply the equation VA and VB? And that VB voltage is also this one, this VB. And we can say this voltage is 0. Why? Because it is directly connected to the ground.
Yes, sir.
Okay. So I just say that this is the VB0. Now the current that is flowing in this direction, it will be go into this direction and this direction. And at this point, the current incoming current, it will all go in this direction only. Why? Because there is no current in this direction. I is 0.
Yes, sir.
Okay. Now you apply that this is the I1 current, this is the I2 current, this is the I3 current, and this I3 current is equal to the I4 current. So I3 is equal to I4. This is the one part. Second part is I1 is equal to I2
Amplifier.
plus I3.
Yes, sir.
Okay. Now if I take the I3 is equal I1 is equal to I2 plus I3. So I1 is what is I1? V
I1 is
in minus VA divided by
2.
R1. This is I am saying R1 is equal to what is I2? VA
VA minus
minus
V out.
V naught upon 1 by C1s. This I am taking as a C1 plus I3 VA
VA
minus
minus VB.
VB, and VB we know that 0, so I
0.
just put as a upon R2. This is R2 resistance. Okay, so this is my first equation. Second equation is what? VA minus VB upon R2 is equal to VB upon 1 by CS.
CS.
So if I solve it, so VA, either I calculate VB, so VA upon R2 is equal to VB upon R2 plus VB by 1 by CS. No, VB is not 0 here. VB is the same voltage.
Voltage across capacitors.
VB is the same voltage. Okay, so VB is not 0. So VA upon R2 is equal to VB 1 upon R2 plus VB 1 by CS. Sorry, 1 upon 1 by C, or we can say directly CS.
CS.
This implies VA is equal to R2 1 plus R2 CS times VB. I just multiply this one. So this. Okay. So this is the value of VA. Now we use this value in a equation number 1 for a simplification. So Vn minus Va upon R1 is equal to Va minus V naught by 1 by Cs C1s plus Va minus Vb by R2. So put the value of Va in this equation, okay, and
Yes, sir.
solve it. So you just get the output of V out upon V in.
Bn. So
Okay.
after that, the QP.
Yeah. Now the if you know the second order equation, so second order equation will be written as a s square plus omega p square plus 2 s zeta omega p. I think this is the
Yes, sir.
equation.
Yes, sir. But the form is changes, sir. The coefficient of s square is 1 by omega p square, and the zeta term is not in the equation, sir. Has to.
I think the
QP is the
equation.
term.
Just wait a minute. The equation will be same, no? Hmm.
In the lecture, sir has wrote it, the equation. The coefficient of a square is 1 by wp square, omega p square.
Okay, you just put as a V naught upon Vi. Hmm. 1 upon 1 plus s upon omega p square plus 2. Just wait a minute, I just check.
S by omega p qp term.
Yeah, s by omega p
QP. That's
s upon plus 2 s by omega p.
நியூக்ளியார் ட்ரெண்ட் ஆனதுனால எலக்ட்ரானிக்ஸ் இன்ஜினியரோட டிமாண்ட்
Into I think 2p. Yeah, s upon omega p 2p.
so there is no two, I think. Yes,
Yeah, that is okay. 1
yes,
plus, yeah. So V naught upon Vi is equal to 1 upon 1 plus s upon omega p qp plus s square upon omega p square, the same equation. Now what we have to calculate it
we know
in this
gain, so
question. Hmm.
from the above equation we know gain, so we can
Yeah,
write.
so the real pole of the quality factor. Okay, so we have to calculate the QP.
There is any general equation for QP, so we can
Hmm?
directly general equation of QP, so we can directly, if you know gains.
Yeah, you can use that particularly. This is a second order quadratic equation. So how you calculate the omega p and how you calculate the QP?
These are the coefficient of a square, and
Yeah,
so in terms of a and b, we can.
exactly. So if I say that my equation will be second order quadratic equation is s square upon omega p square plus s upon omega p qp plus 1. Okay, so I can
minus
equate as
gains.
a s square plus bs plus c is equal to 0. Okay, so what is a? 1 upon omega p square. What is b? A 1 upon qp omega p. And what is c? 1. Okay, so the equation of s roots is, I just apply the minus b plus minus b square
B square
minus
minus
4 ac upon 2a. So minus omega p qp plus minus omega p square qp square minus 4 times of omega p square upon 2a. So 2 upon omega p square. That is the value of s. If I solve that one, so I just divide with the omega p square. 2 upon omega p square, I am just taking upward direction. So this is the minus uh, omega p square upon 2 omega p cube p plus minus omega p square divided by 2 1 upon omega p square qp square minus 4 upon omega p square. Okay, and if I take inside this one, so it becomes a minus omega square, sorry, omega p cancel out, so omega p upon 2 qp plus minus. Now this omega square already, when I take into the square root, so it is a omega p power 4 divided by 4 multiply by 1 upon omega p square qp square minus omega p power 4 divided by 4 into 4 upon omega p square. So these are cancelled out. This is square. This are cancelled out square. So that is the minus omega p upon 2 qp plus minus omega p square upon 4 qp square minus
omega.
omega p square. Okay.
Yes, sir.
Now what we are saying that the poles should be real. Okay, for a given
Then this
circuit,
should
the
be
real
greater than
poles,
0.
the quality factor of QP is. Okay, that means the poles is real means
The discriminant greater than 0.
either this term should be
Greater than 0.
positive or equal to 0. Sorry, basically we can say the greater than and equal to 0. This term should be greater than and equal to 0. If it should be less than, so basically we are getting
Imaginary
a
roots.
complex poles.
Complex.
Okay, so omega p square upon 4 qp square minus omega p square should be greater than or equal to 0. So 1 upon 4 qp square minus 1 should be greater than equal to 0. That means 1 upon 4 qp square should be greater than equal to 1, or 4 qp square should be less than equal to 1. qp square should be less than equal to 1 by 4. That means qp should be less than equal to 1 by 2. Okay.
So I have also getting this.
Yeah. Now what
Yes.
is your qp that you are getting from the equation? V naught upon vi equation that you solve na?
Yes, sir.
On that particular equation, you identify what is your QP. So you apply it not for this equation, for not for the generalized equation, you apply for this equation that you are getting from this particularly solving this one. Okay.
Yes, sir. Sir, from this equation, we only find the gain and we put this gain in view upon v.
Why only gain?
So because v upon v in we will calculate, and this is the gain from this
You are
equation.
getting the omega p also here, no?
The equations we find through nodal analysis. We will
Yeah.
get v out and v in terms of
Yes.
this capacitors and resistance.
Now, after getting this particularly equation, you can calculate the what is the value of QP.
Yes, sir.
Okay. If you get the equation, just tell me, so we will solve the QP value. This is actually basically thing is that you don't know what is the omega p, you don't know what is the QP, so you solve in this way. Okay, you solve in this way, and you assume that QP should be great less than 1 by 2. Okay, but the thing is that when you have the value, you automatically calculate the S value and check that where the QP value will be the basically root will be the positive. Just try by this way. If you have any difficulty, so just tell me.
Sir, if we have a low first order filter, high pass or low pass, so
Mhm.
how we can calculate the cutoff frequency? Sometimes I will confuse in this.
How you calculate the cutoff frequency?
Yes,
So
sir.
basically, thing is that if either you have a low pass or high pass filter, what you have to do is that your equation will be like that one. Okay,
Yes, sir.
like 1 upon I just think that 1 upon 1 plus uh,
Under
10
root.
into 10 raised to power minus 6s. This is
Yes,
my
sir.
equation. Now, how you calculate the cutoff frequency? The either it is a low pass filter or high pass filter, and this is the basically equation of the low pass filter. So I just draw that one. So the equation response should be like that one. Okay, and I initially tell that if s is equal to 0, or basically frequency is 0, so you are getting the maximum magnitude. S is 0, so this is the 1 upon 1. Okay, so maximum magnitude
Yes.
is what? 1. Now, what is your cutoff frequency is that when your magnitude will be reduced up to the 3 dB, or 1 upon root 2 times of the maximum. Okay, 1 upon root 2 time of the maximum.
Maximum.
That particularly frequency is called the cutoff frequency, omega.
Sir, there is a formula, na? The cutoff frequency is governed by RC. So,
That is basically for the ideal case. What we are doing, that we are saying that 1 upon 2 pi RC f.
yes, sir.
Okay, But better way is that don't use this formula, just calculate the V naught upon Vi and put this value with the maximum. This is the gain. If it is a 1, so we can say if your magnitude will be reduced by 1 by 2 times of the 1, so that frequency is your cutoff frequency.
Yes, sir.
Okay, so what you have to do, 1 upon root 2, that is equal to 1 upon, now if we calculate the magnitude of this one, so what is the magnitude? 10 into 10 raised to power minus 6 j omega. So 1 upon root 2 is equal to, how we calculate the magnitude? It is a complex term.
So
So root of real component square plus
imaginary components.
imaginary component 10 raised to power minus 5 omega whole square.
Yes, sir.
Okay. Now take a square. So this root and this root will be cancelled out. So you can say 2 is equal to 1 plus 10 raised to power minus 5 omega whole square. This means 1 is equal to 10 raised to power minus 5 omega square, omega whole square. If I take a square root, so 10 raised to power minus 5 omega is equal to 1, omega is equal to 10 raised to power 5. And
Yes,
f
sir.
is 10 raised to power 5 divided by,
2 pi.
it is in hertz, it is in radian per second. Clear?
Yes, sir.
So this is the only way. Just calculate the V naught upon Vi. Then, because the thing is that if the circuit is minus, just wait a minute. Hello. Yes. So basically, if my circuit is given like, okay, this is the R1, R2, R3. Now, how you calculate the frequency? F is equal to 1 upon 2 pi R. Okay, but
So
the thing is
yes,
that which R you consider? This one, this one, this one, and what is the magnitude about that one? Because there is the R2 upon R3. So that will be providing me the gain 1 plus R2 by R3.
yes,
Okay, so how should I say that it is a
sir.
1? Clear? Because
Yes,
there is
sir.
a
So
gain also. So like for example, we getting the transfer function of 100 into 1 plus 10 raised to power minus 5 omega. Now this is my transfer function I am getting. So what should I do in this case? I have to equate this one with 100 upon root 2, not 1 upon root 2. Why? Because the maximum magnitude is 100.
Yes, sir.
Okay. So my calculation is completely changed, and in that scenario, your 1 upon 2 pi RC formula is failed. So the better way is that you can use the V naught upon Vi and
Then compare with root 2, divide.
yeah. And basically, in the second order, in the second order, like for example, we have a two RC pair, and both R will be changed. So you can use the formula of that one also. But better that we can go with the V naught upon Vi and put it as if 1 upon root 2 of the maximum. Okay.
Yes, sir.
Any other doubts? Yes, any other doubts?
No, sir. No, sir. No doubt, sir.
Okay, so I think we will stop here because no one is there.
Okay, sir. Okay, sir. Thank you, sir.